In this video, we're going to discuss non-homogeneous equations. First off, what is a non-homogeneous equation? Recall that a nth order linear differential equation of this form is homogeneous, which means that our function over on the right is equal to 0. A non-homogeneous linear differential equation has this form up here where g of t is not 0. So g of t does not equal the 0 function. Okay, so we continue on here and we say that if we have some function x sub p is a solution to the non-homogeneous equation, we call that a particular solution of the differential equation. Moreover, let's discuss what the general solution to the non-homogeneous equation is. That's actually quite simple here. It is just the solution, the general solution to the homogeneous equation, which we've already discussed about in the previous video, plus a particular solution to the non-homogeneous equation. This gives us a general solution to the non-homogeneous equation. So what does that mean? That means that all solutions to this linear differential equation up here have this form where x1 through x sub n are solutions to the non-homogeneous linear differential equation, and x sub p was a particular solution to that first non-homogeneous linear differential equation, which gives us a pretty simple way to solve these general solutions to a non-homogeneous equation just by separating it into two types of problems. So let's do example 6 here. We have 3 parts, so 3 different linear differential equations we want to try to solve here. So for part A, we want to find the general solution to x double prime minus x is equal to 1. We notice that x double prime minus x equal to 0 has the solution x equal to c1 e to the t plus c2 e to the negative t. We had actually solved that non-homogeneous equation in a different video. Then the general solution to x double prime minus x equal to 1 is just the sum of the non-homogeneous solution and some particular solution. Well, notice that a particular solution to this up here is just x is equal to negative 1. If we plug in x equals negative 1, then we do in fact get positive 1 there. The second derivative of negative 1 is 0, so we get 0 minus negative 1 is equal to 1. So we notice that x sub p of t is equal to negative 1. Now, in this case, we just kind of guessed that. We will find solutions for determining this particular solution later on, but for right now, we just guessed that that was a solution and noticed it worked. So this tells us that our general solution is c1 e to the t plus c2 e to the negative t minus 1. And this is our solution to the first linear differential equation up above. All right, let's do the second one. Well, again, we've already noticed that x double prime plus x equal to 0 has a general solution of c1 cosine of t plus c2 sine of t. Right? It's because cosine of t satisfies this equation. Sine of t satisfies this equation. Cosine of t and sine of t both form a fundamental set of solutions. And so this is our general solution to the homogeneous equation x double prime plus x is equal to 0. Now, we want to find the general solution to the non-homogeneous equation up here. So we notice that a particular solution can be x is equal to t. Because if we plug that in, x double prime is 0 here. So if we plug that into this equation, we get 0 plus t is equal to t. So we see that x sub p of t, so our particular solution, x equal to t, does in fact work. That tells us our general solution to the non-homogeneous equation is the solution to the homogeneous equation. Oops. Plus the particular solution. And we are done. That is our solution. So any equation of this form is a solution to this differential equation up here. I actually invite you to try that out. Plug in any constant C1 and C2 that you wish. Find the second derivative of that function, and then plug the second derivative and the original function into this up here, and you will see that the output will be t every time. All right, let's try to find our solution to x triple prime is equal to e to the t. Again, let's solve the homogeneous equation first. And in the previous video, we have already found that the general solution to this homogeneous equation is C1 plus C2t plus C sub 3t squared. So this is a general solution to the non-homogeneous equation, to the homogeneous equation, x triple prime is equal to 0. And now let's find a single solution to the to the non-homogeneous equation, x triple prime is equal to e to the t. So one particular solution to this is e to the t, because the third derivative of e to the t is just e to the t. So this tells us that our general solution to the non-homogeneous equation, which is this one up here, is equal to the solution to the homogeneous equation plus a particular solution. And so again, any solution of this form, or you can plug in any constants for C1, C2, and C3, if you find the third derivative of this function, it will in fact equal e to the t. And moreover, all solutions are of this form. All right, and that ends this video.